In this lecture, we take a look at the relationship between the inscribed and the central angles of a circle. An angle that is inscribed in a circle has its vertex on the circle. Suppose this vertex is the point A. Each of the two rays that form the angle extends from point A and intersects the circle. We designate these points of intersection as B and C. And so the inscribed angle is angle BAC. A feature of an inscribed angle is that a portion of the circle lies inside the angle. This portion is called the intercepted arc. Now, to each intercepted arc, there is a corresponding central angle, and its vertex is the center of the circle. Each ray of the central angle extends from the center of the circle to an endpoint of the intercepted arc. And so the central angle is angle BOC. The situation that we present here has the center of the circle inside the inscribed angle. The other situation would be to have the center of the circle outside of the inscribed angle or on one of the rays forming the inscribed angle. But the discussion will be very similar for the situation that we present here, and we leave it as an exercise for the viewer to show that one gets exactly the same result as the one that we present in this lecture. To determine a relationship between the central angle and the inscribed angle, we examine the angles of certain triangles. We construct segment OA to get the first triangle, which is triangle AOB. We observe that two sides of the triangle, namely segments OA and OB, are congruent because they are radii of the same circle. And so triangle AOB is isosceles, so that the base angles are congruent. We'll denote the measure of the base angles as little a, and the measure of the apex angle as x. Similarly, for triangle AOC, two of its sides are radii of the circle, and so are congruent. And therefore, triangle AOC is also isosceles, so that the base angles are congruent. We'll say that the measure of the base angles is little b, and that the measure of the apex angle is y. For the third triangle, we construct segment BC, and so we have triangle BOC. And again, two of the sides of triangle BOC are radii of the same circle, so that triangle BOC is isosceles. Therefore, the base angles are congruent, and we denote the measure of the base angles by little c, and the apex angle by z. At this point, we use the fact that the sum of the angles of a triangle is 180 degrees to generate a set of equations to lead us to the relationship between the central angle and the inscribed angle. Starting with triangle AOB, a plus x, or 2a plus x equals 180 degrees. In triangle AOC, b plus y, or 2b plus y equals 180 degrees. And in triangle BOC, c plus z, or 2c plus z, equals 180 degrees. We have one more equation to go, and that is for triangle ABC. For triangle ABC, we have a plus b plus c plus c, or 2a plus 2b plus 2c equals 180 degrees. Since the very first central angle that we had mentioned at the start of the lecture is angle Z, we use the third equation and solve for 2c. 2c is equal to 180 degrees minus z, which we plug into the last equation, to get 2a plus 2b plus 180 degrees minus z equals 180 degrees. We subtract 180 degrees from both sides of the equation, and we get 2a plus 2b minus z equals 0, or simply 2a plus 2b equals z. Or in factored form, we have 2 times the quantity a plus b, which is twice the measure of the inscribed angle BAC, equals the measure of the central angle, z. Therefore, the rule is that the measure of the central angle is equal to twice the measure of the inscribed angle that intercepts the same arc.